All right, we are on question 29. So this is a little bit with, how do we read a graph, but it's also a little bit, comparing one graph and how it's been transformed to another graph. So first, what we'll want to do is put arrows on these if you didn't do that yet. And I do encourage you to go through your graph and mark some of these. For this problem, you'll need the end behaviors. So for this one, x is getting bigger, y is getting bigger. And then its vertex is about -3, -2. We need those. I've already answered the question, so I know that. So for this one, same end behaviors. As x is getting smaller, y is getting bigger, and as x getting bigger, y is getting bigger. Let's wrap these in parentheses. And its vertex is 0, 0. Okay, so the first thing is you're going to answer, is it f of x, g of x, both, or neither? So which one has a vertex at -3, -2? That's your g of x. Which one is decreasing from -infinity to 0? So this is decreasing from -infinity to -3, but this one's decreasing from -infinity to 0. So for that problem, it's f of x. Which one is positive on the interval -infinity to infinity? So that means it's above the x-axis, the entire thing, and that's this one. From -infinity to infinity, this is all above the x-axis, so that one again is f of x. Which has a domain of -infinity to infinity? That's actually both. So this one, its lowest x value is -infinity to infinity, and the same for this one. Okay. Which one has a range of -infinity to infinity? Well, g of x has a range of -2 up to infinity, and this one has a range of 0 up to infinity. So this is actually none, neither. Draw blank, whichever. Which one has a relative max? Neither of them do. So I'm going to do that this time. And if so, describe it. We don't have to do that. Which one has a relative min? They actually both do. Remember, we're now looking just if it's a vertex, it's a min. And don't write these coordinates. We write it -2 when x equals -3. And then the other one is 0 when x equals 0. Okay? All right, next one. This is the whole thing from the gallery walk, so I got a lot of questions to answer before I answer any of those questions. Sorry. I'm going to go through and label my graph. So first the ends. X is always getting smaller on the left, bigger on the right. So what's y doing? Here in the end, it's getting bigger and bigger and bigger, so I put infinity. And the same over here. In the end, y is getting bigger and bigger, so infinity. I mark the intercepts, so here's my x. Here's the other x. There's 2 of them. My y-intercept. And then I mark my turning points, which is right here. And again, on the test, if you don't do this, I don't grade the question, because I'm going to look at your numbers and go over here and not compare your answers to my answers. So as x is getting bigger, that's the side, y is getting bigger. And as x is getting smaller, that -infinity, that's over here, y is getting bigger. So these are both infinities. That's not a very good infinity symbol. What are my x-intercepts or my zeros? There's 2 of them. Here they are. My y-intercept, 0, -3. Let's see, relative max. There is no relative max. But there is a relative min. It's -4 when x equals -1. My interval of increase. So as I go left to right, where's the graph increasing? Well, here it's decreasing, but when I get to my minimum, now it's increasing from -1, look at the x value, up to infinity. And I'm always going to use parentheses on interval of increase and decrease. So the interval of decrease is from -infinity down to -1. Positive intervals. This is above the x-axis. This is below the x-axis. So above the x-axis is here, and it's here. and it goes from negative infinity to negative 3 as 1. And then the other one is from 1 to infinity. Again, just use the x coordinates. The only time we use y is for the range. So my negative interval, that's just this part below the x-axis. And that starts at negative 3 and it ends at 1. My domain, left to right, my lowest x value is about here, negative infinity, to my biggest x value, which is over here, infinity. And biggest means to the right. It's not that this is the highest, it's to the furthest right. And then my range, the lowest y value, this is the only time we use y, is negative 4, and the biggest are the infinities. And this I'm going to use a bracket because it is including 4. Okay, and that's our first bracket that we've seen so far. All right, next one, same thing. Bunch of questions to answer. I am going to do my ends. So again, on the left, x is getting smaller. On the right, x is getting bigger. So in the end, what are the y's doing? They're getting smaller. And in the end, what are the y's doing? They're getting bigger. I'll do my intercepts. And as it turns out, this is also the y-intercept, and I'm going to do turning points, so negative 2, 4. And this is also my turning point, which I've got marked. So first thing is, as x is getting bigger, over here, y is getting bigger, and for x is getting smaller, y is getting smaller. So I'll have one of each, infinity. All right, my x-intercepts, my zeros are negative 3, 0, and 0, 0. My y-intercept, right there, 0, 0 has a couple jobs. My relative max, here's a vertex, that's a high turning point, so it's 4 when x is negative 2. And my min, my low turning point, is right here. It's 0 when x is 0. Interval of increase, again, look left to right. Where is it increasing? So from left to right, it's increasing here. Now it's decreasing, and then it's increasing here. So when I start the increase, I start at negative infinity until I get to negative 2. And then I got my decrease, but when I started again, I'm at 0 up to infinity. And then my interval of decrease going down, it starts at negative 2 and goes to 0. And again, this is parentheses because negative 2 is used twice and 0 is used twice. Since it's being shared, it's parentheses. Positive interval above the x-axis, negative interval below the x-axis. So for this one, I'm just going to write this as one entire above the x-axis. So it's going to go from negative 3, I'm not going to stop, all the way up to infinity. Just make it 1. And the negative interval, just this one little part here, it starts at negative infinity and goes to negative 3. Domain, left to right, first is that negative infinity. The last is this infinity. And again, the only time I'm going to use y is for my range. So my lowest y is negative infinity up to my highest y, which is infinity. All right, so we got a couple questions to answer on this one. So the graph below represents the percent of carbon dioxide remaining in the atmosphere years after the carbon dioxide was emitted. So it's going down, and use the graph to answer the questions. So first one, over what interval is carbon dioxide increasing? So it's never increasing, it's decreasing, so none. Over what interval is carbon dioxide decreasing? So I guess what makes sense of the graph is, this does keep going here, and so does this. But the first x value that I'm actually going to use is right here because I'm not going to have negative time. So it's decreasing starting at 0 and going to infinity. So, you know, we mark these important points. There's the left arrow. Here's this. And then my right arrow. And then let's actually talk about this y value. So it's starting to flatten out, and if you notice it's flattened out right about 20. So it's going to get closer and closer to 20, but it's never going to reach 20. So look out for those exponential growth and decay. Where is it flattening out? Because it's not, y is not going to go to infinity. It's going to get close to 20, but never quite get to 20. So over what interval is carbon dioxide decreasing? Again, we want to use the x. I would say you say from 100 and to infinity. So you could do it two ways. You could write it like this, from 0 to infinity is the correct way. You could even say, no, let's just leave it like that. For what interval? It's just reading the graph. Based on the data, which type of function would this most closely model? Exponential, I'm going to abbreviate decay because it's going down. Assume the data were represented by a continuous function. What would the domain of the function be? So continuous just means it's going to keep going, and we kind of already answered that here. So I would just say this, unless I read that one wrong. Assuming the data were represented by a continuous function, how much carbon dioxide would be present after 400 years? So again, this is flattening out at 20, so it's never going to quite reach 20. So even at 400, 700, 1,000 years, it's going to be about 20. Not quite 20, but about 20. All right? All right, moving on. So on the test, you will be, first, we're going to take this one off, okay? I'm not going to put any vertical stretches and compressions on there. Excuse me. So actually, I take that back. Now I look at my work, I took out the 2 here. So we left that one. We're taking this one out. Won't worry about that one. And we are going to give the parent function, and then we're going to discuss the transformation and graph it. So my parent function we did talk about looks like this. We graph these easy points, 0, 0, 1, 1, negative 1, 1, 2, 4, and negative 2, 4, and then 3, 9, and negative 3, 9. So I've got that shape, but I'm actually not going to graph this one because the transformation is so subtle that it's really hard to sell the old points and the new points. So this -1, so this is outside, it's not inside, this is inside, and when it's inside something, we're saying it's in the house. And so this is outside. Adding, subtracting, outside, here's the parent function, means it's going to go down 1. So all these points are just going to go down 1. I'm just going to mark them differently. Down 1, down 1. And I realize on your graph paper, or on your yellow paper, because I did this on yellow too, the graphs are really bad. So sorry about that. They will not be like that on the test. And just do your best to connect the new ones. So I didn't do very well. All right, the next one. So I want us to go ahead and try the 2. So you got your absolute value function, which I'm just going to graph a few of these points. I don't need to graph them all. Okay, I got this V shape. So what's going to happen is I've got these key points. I'm just going to take the ones I graphed. So when x is negative 10, y is 10. When x is negative 5, y is 5. When x is 0, y is 0. And these points. Okay? That's the parent function. So what this 2 is going to do is take all these y values and stretch them. And they're just going to stretch by me multiplying by 2. So it becomes 20, 10, that stays 0, 10, and 20. So what's going to happen is I'm going to have these temporary points. So first, negative 10, 20, and 10, 20 aren't going to fit. So, but negative 5, 10 will. So we graph that one. And 5, 10 will. and 0, 0 will stay where it is. So this is where I am right now. You can see it's skinnier. It's stretched it. And now this minus 1 is going to take everything and move it to the right. So first, here's my parent function. The transformation, it's going to stretch by 2. And then it's also going to go right 1. So when it's in the house, you need to ask yourself what will make this 0. And 1 will make that 0. And since it's a positive 1, they're going to go to the right. So I've already done my stretch by 2, but now I'm just going to take these points and I'm going to move them right once. So here, here, and here. Hopefully you can tell the difference between all these different points. And then I'm going to connect them. Hopefully you do a better job connecting than I do. And the last one, so we took out the 2. So we've got our parent function, x squared. So again, here it is, 0, 0, 1, 1, negative 1, negative 2, 4, and 2, 4, and 3, 9, and negative 3, 9. So first the negative is going to take all these points and just flip them. So if we do make a t-chart, so negative 3, 9, negative 2, 4, negative 1, 1, 0, 0. It's going to basically, I'm taking all of these y's and making them negative. So now it's negative 9, negative 4, negative 1, 0 still 0, negative 1, negative 4, negative 9. So they're all going to switch upside down. So this one will stay where it is. Now these are down here. And those have flipped. And these points have moved all the way down here. Okay, so I've got an upside down parabola now. And now I'm going to do the rest of the transformation. So this plus 1, it's in the house. I ask myself what's going to make it 0. So first it flipped. Negative 1, so it's going to go left 1 because of the negative. And the plus 3 is out of the house. That means it's going to go up 3. So each point now, after I flipped it, it's just going to go left 1, up 3. So here's 0, 0, left 1, up 3. And I'm going to use an X. And this point, left 1, up 3. And this point, left 1, up 3. This point, left 1, up 3. And that lands on a point. And this one, left 1, up 3. Left 1, up 3. And just connect the final one. Not very good, but I tried my best. And I think that's it. All right. See you test day.